Hello and welcome to our channel. Today we will discuss a fascinating and ambitious topic, terraforming Mars. Can we really transform the red planet into a new world suitable for human life? Mars has long been a target for space exploration, but it's not just about sending probes or astronauts. Many dream of a future where we could live on Mars by turning it into a second Earth. Known as the red planet and the fourth planet from our Sun, it is the second smallest after Mercury. Its nickname comes from the fact that its ferrous rocky surface gives the planet a reddish-copper appearance in the night sky. It has been the subject of study for decades, with NASA and other space agencies having sent a series of orbiters, landers, and rovers to explore its surface. These missions have revealed that Mars is a much more complex world than initially thought. The planet has a varied geology, with the highest mountains and the deepest and longest canyons in the solar system. Olympus Mons, for example, is the largest known volcano, standing about 22 kilometers high, nearly 3 times the height of Mount Everest. The Valles Marineris, on the other hand, is a canyon system over 4,000 kilometers long. Mars' surface is characterized by impact craters similar to those on the Moon, but it is also covered by oxidized iron dust, which gives it its red color. Mars has a thin atmosphere, composed mainly of carbon dioxide with traces of argon and nitrogen. This atmosphere is not dense enough to protect the surface from solar radiation, a significant obstacle for any human missions. One of the most interesting topics of research on Mars concerns the presence of water. It is thought that in the past the planet had a denser atmosphere and was warm enough to support liquid water on its surface. Today, however, it is known that water is present only in the form of ice, mainly at the poles. Mars is also the most habitable planet in our solar system, outside of Earth, despite its extreme conditions. Scientists believe that life may have existed on Mars in the past. Moreover, with the right technologies, it might be possible for humans to live there in the future. The colonization of Mars is considered a topic of intense debate. Some see this as a necessary step for the survival of the human species, while others raise ethical and practical concerns. Over the last decade, the race to explore Mars has intensified. In the future, missions will focus not only on searching for evidence of past life but also on how we might sustain human life on the planet. Whether we succeed or not, only time will tell. Mars remains a fascinating mystery and a symbol of our innate desire to explore the unknown. Several future missions are already planned. They aim to collect samples from the Martian soil and bring them back to Earth for further analysis. This would be a significant step for our understanding of the red planet and could provide answers to many questions about its geological history and the possibility that Mars could host life forms. At the same time, the private industry is becoming increasingly involved in its exploration. SpaceX, the aerospace company founded by Elon Musk, has stated its goal to send humans to Mars within the next decade. But is it possible? And how could we do it? Let's find out. Before we continue, if you like the video, don't forget to subscribe to the channel and activate the bell to stay updated on upcoming videos. First, we should ensure that Mars has a breathable atmosphere, currently composed almost entirely of carbon dioxide with traces of nitrogen and argon, but without oxygen. Humans cannot survive in these conditions. There are many innovative proposals regarding the possibility of importing oxygen. One of the most fascinating solutions involves the use of photosynthetic organisms such as algae and genetically modified plants capable of withstanding the harsh Martian conditions. These organisms, in addition to enduring extreme temperatures, intense solar radiation, and low atmospheric pressure, should be able to convert the abundant Martian carbon dioxide into oxygen through photosynthesis. This could not only generate a breathable atmosphere but also contribute to the creation of a vital life cycle for long-term survival on the planet. However, many challenges lie on the path to this vision. The genetic modification to create such organisms is complex, and the need for a significant amount of water for their development represents a significant obstacle since Mars only has it in frozen form concentrated at the poles. Moreover, there is a risk of biological contamination of the planet. One of the main barriers to the colonization of Mars is its extreme temperature, with averages hovering around -80 degrees Celsius. Martian conditions are hostile to human life. The main cause of this cold climate is the planet's thin atmosphere, which is not capable of retaining heat like Earth's atmosphere. Faced with this challenge, scientists are studying methods to warm Mars. One possible strategy involves releasing greenhouse gases into the Martian atmosphere. These gases would be able to retain more heat, increasing the greenhouse effect and thus the planet's temperature. Another innovative proposal involves the use of orbital mirrors. These mirrors, positioned in space around Mars, could reflect additional sunlight onto the planet's surface, contributing to its warming. Besides the known scientific and logistical challenges that exploring Mars entails, there are fundamental issues yet to be addressed. One of the most significant is the lack of a protective magnetic field on Mars. This leaves the planet vulnerable to solar and space radiation, posing risks to the life and health of astronauts. Another problem is the low Martian gravity, just 38% of Earth's. This could have detrimental effects on human health over the long term, including bone and muscle mass loss. It will be necessary to study and implement strategies to mitigate these effects. Finally, accessing water on Mars presents a formidable challenge. Although there are indications of ice water, converting it into usable liquid water requires energy and sophisticated infrastructure. Water is vital for human life in many technologies, so solving this problem will be crucial for any habitational missions on Mars. We have highlighted two of the most important missions that have sought to address some of these challenges. In second place, the Mars Terraforming mission, carried out by NASA, aimed primarily at solving the issues related to gravity and temperature on Mars to make the planet more habitable for humans. Regarding the gravity issue, the mission studied the possibility of increasing it through centrifugation, a process that uses centrifugal force to replicate the effects of gravity. In terms of temperature, the mission aimed to raise the planet's average temperature. To do this, the mission experimented with releasing greenhouse gases into the Martian atmosphere with the intent of triggering a greenhouse effect that could warm the planet. Additionally, the mission explored methods of generating heat through the use of orbiting mirrors to reflect sunlight onto the planet's surface. In first place, the Green Mars project, led by the European Space Agency, ESA, in collaboration with several universities and research centers, sought to resolve the problems of gravity and temperature on Mars. For the gravity issue, the project aimed to use gravity modulation technology that might allow astronauts to live and work in an environment with gravity similar to Earth's. For the temperature issue, the project attempted to use a technique called cometary bombardment, which would involve sending icy comets to Mars. The goal is that by impacting the planet, the comets would release their ice, triggering an increase in temperature and atmospheric pressure. Additionally, the water released could help create a more hospitable environment for humans. Everything we have discussed in this video outlines the complexity of exploring and colonizing Mars. But with ongoing research, determination, and innovation, one day the red planet might truly become a new place to live. So, what do you think? Is terraforming Mars a dream we should pursue? Write it down in the comments below. And remember to subscribe to the channel and activate the bell, if you haven't already, to stay always updated on upcoming content.